Hi everyone. Today we're going to be reviewing and talking about galaxies. Let's go ahead and jump right in. First off, this is a picture of what we call the Whirlpool Galaxy. The Whirlpool Galaxy is a particular type of galaxy called a spiral galaxy, and let's see if we can tell what's inside of it, because really we define a galaxy by what's in it. In the reading yesterday, I think the definition that they use for galaxy is a huge collection of stars, dust, and gas held together by gravity. And I think that's a pretty accurate definition. So we can, as we look at this structure that's on the screen in front of us, the Whirlpool Galaxy, we can see all these bright dots. Those bright dots are stars, but they're not singular stars. Those are actually clusters of stars. So there may be thousands or even millions of stars inside of each one of those little pinpricks of light that you see there. Um, so there are not only there's not just one galaxy. Our solar system happens to be part of a galaxy. This is the Whirlpool Galaxy, but there are many, many, many others. As a matter of fact, we can't count them all, but we estimate that there are billions and billions of galaxies in the entire universe. These galaxies are not very close together. These are very big structures, but they are very, very far apart. I think in the reading yesterday, it mentioned that these galaxies are millions of light years apart. Now, light year is a distance, it's a measurement that most of you probably don't understand very well, but it turns out to be, many trillions of miles. And so, galaxies, I think the key parts here are what they're made from: stars, dust, gas, and that they contain lots of stars, billions, in fact, for large galaxies, and that there are billions of galaxies. So there's not just a few galaxies, there are many, many galaxies. And finally, that these galaxies are very far apart. Those are some really big ideas about galaxies. So, how do we know what we know? Uh, we know what we know because we have put space telescopes in orbit around Earth. This is a picture of the Hubble Space Telescope. And so most of the pictures that we'll be looking at that show some of the space objects today will have been taken using the Hubble Space Telescope. Hubble is not the only space telescope we have. There are actually several others, but we will mostly focus on Hubble and what it can do early on while we're talking about some of these big structures in space. So this is a picture that was actually taken by Hubble. This is called the Hubble Deep Field Image. And this kind of changed what we thought we knew about our place in the universe. And the reason this picture is so important is because scientists pointed the Hubble Space Telescope into the darkest part of the sky where they could see nothing. And they let it take pictures of that dark part of the sky and collect light for, I think, 10 days or so. At the end of that 10 days, this is the picture that came back. Every one of these things you see, with the exception of this right here, which is a nearby star. This is probably a star in our galaxy. The rest of these bits of light and shapes, these are all galaxies. And you can see that there are galaxies that of all shapes and sizes and colors. Some of these galaxies may be very, very, very far away from us. Others are going to be somewhat closer, so it's a little bit difficult to tell about the size of them. But this was a picture taken where we thought there was nothing. So it turns out that the universe is very wide and there are lots of these galaxies out there. Remember, we've said billions and billions. When I keep using the word billions and trillions and millions, and I just want to take a moment to give you some way, some sort of visual that you can use to compare those numbers. I think a lot of times when I start talking about space, students really have no concept of the difference between those things. And we're going to try to see if we can draw that comparison by using money. So we're going to start out with a $100 bill. Some of you have maybe held one of these in your hand. Others of you haven't. I rarely hold one. But a single paper bill is very thin and very lightweight and very small. You may know that at the bank they package bills together. They package paper money together. So if we were to put several of these together, a packet of $100 bills, So I guess there would be 100 of them. 100 of these things would really just fit in your back pocket. So it would be about half an inch thick, and it would equal about $10,000. So this is relatively palm sized. So that's $10,000 in $100 bills. If we were to have $1 million, and million is that first number that we throw around a lot, $1 million would be 100 of those packets that could fit in your back pocket. So looks like, and you can see that shape there on the ground, that's 100 packets of $100 bills. So that looks like it would fit in a briefcase. So that's maybe what $1 million would look like if we had it in $100 bills. So you can see the size of that relative to the person that's standing next to it. This is where we get a big jump. Now, please recognize up at the top, we are not up to $1 billion, right? So this was our $1 million. It's about the size of a briefcase, but we need to introduce sort of what we're doing here. This is a pallet full of $100 bills. And so some of you know what I mean. Those pallets are what maybe are loaded onto trucks and forklifts unload them. So this is what $100 million would look like in $100 bills. So you can see it's a little over waist high. It really turns out to be 3 feet by 3 feet by 3 feet, roughly. And so, that looks like a lot of money. So $100 million. So when we compare a million to a billion, remember a million fit in a briefcase? This is what $1 billion would look like. $1 billion in $100 bills would equal 10 of those pallets. 10 pallets, each pallet 3 foot by 3 foot by 3 foot. It's pretty incredible when you look at it. So when we say a billion, there's a very big difference between a million and a billion, right? So it only looks like 3 more zeros, but those 3 zeros mean a lot. And here's what $1 trillion would look like. So when we talk about something being a trillion, these are all pallets of money. Now, I need to draw your attention over here. This is that same person, okay? So to scale, this is the same person that has been shown in those other drawings. But he's standing next to those pallets that are representing $1 trillion in $100 bills. Please notice, by the way, that these pallets for $1 trillion are double stacked. So we've had to stack we've had to stack a pallet on top of another pallet. So they're double stacked. And so this is what $1 trillion looks like. So when I throw out numbers like, million, billion, trillion, try to keep in the back of your mind this example. Remember, $1 million, that would fit in a briefcase. $1 billion, well, that's 10 pallets. And if I use the number trillion, which is 12 zeros, we're talking about something that's almost unimaginable. We're talking about a number that is very, very big. When we talk about galaxies, we also need to talk about something called a nebula. So a nebula is just a huge cloud of gas and dust that's found inside of a galaxy. So if we think back to our definition for a galaxy, we said a galaxy is a huge collection of stars and of gas and of dust. So a lot of that gas and dust is trapped inside of these nebulas. Some things that I would want you to keep in the back of your mind about nebulas is this is where new stars form. So inside of this nebula, this nebula contains the raw materials that new stars are formed from. They're actually beautiful to look at. This was a picture of the Orion Nebula. This was, of course, taken by the Hubble Space Telescope. Nebulas, when we see them, are often shown as being very, very colorful. The colors here are glowing gas. So with some of that red that we see glowing there in the background, that's hydrogen gas glowing. We can see some of the blue gas that is up and around the outside edge and also sort of permeating through here, that is oxygen gas. And up in here, we can kind of see some of the dust clouds. We're able to see the dust a little bit better here because it's being backlit by these stars. So this is some of the dust. So a nebula is just a huge cloud of gas and dust that's found inside of a galaxy. According to the reading yesterday, we have 3 different types of galaxies. Okay, and when we say 3 different types, this is not meant to be confusing. Scientists really just looked at galaxies as they were looking at some of these pictures taken of our universe, and they thought, let's group them by the way they're shaped. So the 3 basic shapes of galaxies we have are elliptical. Okay, so an elliptical galaxy this is a great example of what one would look like. Often they're sort of circular, maybe a squash circle, and it's a cluster almost of really tightly packed stars. So the stars are very, very close together. There's very little gas and dust inside of an elliptical galaxy. Another shape that we have is a spiral galaxy. This is in some ways the most familiar type because the galaxy that you are part of, the Milky Way galaxy, is a spiral galaxy. Some of the key features of a spiral galaxy as we can see there in the center, we have that very, very bright galactic core. Sometimes that core in a spiral galaxy will contain a black hole, a very large one. And surrounding and rotating around that central core, we also have those spiral arms. And we can see that the one here in the picture has 1, 2, 3, 4 spiral arms. Sometimes I like to imagine these are shaped like a pinwheel, if you know what a pinwheel is. All right, so we got elliptical, spiral shapes, and then the last one is a little bit of a catch-all. It's called an irregular galaxy. An irregular galaxy just doesn't have an irregular shape. Each one of them is a little unique, and it's kind of like the category that's the catch-all when they don't really know how to classify a galaxy. So if it isn't quite elliptical and it isn't quite spiral, we would often just classify it as an irregular. And we have a great deal to learn about the irregular galaxies, but it is an area of current study. If you look underneath each one of these basic shapes across the top, these are actual pictures taken by Hubble of some of each type of galaxy. So this would be an example of what an elliptical galaxy would look like through a telescope. This is not the Whirlpool galaxy, but we can now know that that first galaxy we looked at, Whirlpool, was indeed a spiral galaxy. And here we can see an irregular galaxy, and you can see that it doesn't quite fit the form of either of those other two. All right, so the way that I'm going to get you to finish out today is you're going to need to get some notes in your notebook. Okay, so we haven't taken notes in our notebook yet. I can tell you that I'm particular about your notes. Okay, so I'm going to need you today to pause this video and to copy these notes directly into your notebook. So here's some rules about notes. The notes that you put in your notebook, they have to be neat. They have to be readable not only by you, but by me. You need to slow down and take your time. I will grade your notes. These notes turn out to be a really helpful reference for you as we move through the year. So make sure you can read them and that you take your time with them. Your notes need to be written in pencil. No pen, please. We make mistakes, and that's the way it is, and those mistakes are easier to fix when we're writing in pencil. Your notes must have a header. We can see here that the header for these notes, it says Notes, Galaxies. Okay, so you must put a header, and I want your header to appear on that top line, just like mine does. And please notice that I've skipped a space. I've skipped an entire line after my header before I started the notes today. Your notes must be dated. This is helpful because this tells us the date that we actually took these notes. Get in the habit of always putting a date on anything you put in your notebook. We won't number our pages. I won't make you keep a table of contents, but I do expect things to have a header, to be titled sort of, and to also have a date. Please notice here that I've highlighted some key vocabulary words. You should use your yellow color pencils to very lightly shade. Notice that I said yellow. Please don't use other colors. So highlight the key words, and we have 4 key words from our notes today: light year, galaxy, Milky Way, and also nebula. Your notes must say exactly what mine say. So if it is written on my page, you have to write all these same words. Please don't abbreviate my notes further. These are already abbreviated. When I score your notes, I'm going to look to see, did you write what I did? One of the key bits that I want you to understand is your notes are meant to be useful for you. And by that, I mean I will absolutely allow you to use notes. I'll use your notes anytime we take a quiz or a test. So make sure your notes are in good shape. Your notes really are going to have a big impact on how you do in this class. So Take care and take them well. I think that will about do it for today, guys. So have a good day away from me, and I hope to see you guys very soon.